Okay, so we should be on the last recording. Now, half-life means that you lose half of whatever you started with every time a half-life occurs. So this has a half-life of 500 years. After 1,500 years, then I should have gone through 3 half-lives, because 1,500 divided by 500 would give me 3. So to go from my beginning to the first half-life, I lost 1/2 of it. From 1/2 to the next half-life, I have 1/4. And from 1/4 to the next half-life, I have 1/8. So I should have 1/8 of that left. 1/8 is 12.5%. If you don't know how I got that, I took 8 and divided it into 1.00 and then multiplied that by 100. And so 0.125 times 100, because I wanted percentage, is 12.5%. Remember, I started out with a whole. After 1 half-life, I had a half. Now I have half of that. Well, half of half is a fourth. Half of a fourth is 1/8. So that's all I'm doing. Next setup says if you start off with 100 grams of uranium-238, how much would you have left after 4 half-lives? So the easiest way to do that is to go to 100, down to 50, and that was your first half-life. 50 down to 25, and that was your second half-life. 25 down to 12.5, that's your third half-life. And 12.5 down to 6.25 grams is your fourth half-life. So you would have 6.25 grams. All right. Then I went to answer the next part. It said, what if you started off with 200 grams? Well, isn't 200 grams twice as much as 100? So 6.25 times 2 is 12.5. If you don't want to do it that way, do 100. Do 200 down to 100, first one. Down to 50 grams is your second one. Down to 25 grams is your third one. And then down to 12.5 grams is your fourth one. Okay, if you started with 500, that's 5 times that. So 5 times 6.25 would be 31.5. If I did my math correctly, 31.25. Let me see if that makes sense. That's 30, I don't know if I like that math, so let's do it real quick. 6.25 times 5. That's 12. There we go. Yeah, 31.25. Now, if you don't want to do it that way, then just start out with 500. Cut it in half, 250, and that's your first one. Cut it in half, 125, that's your second one. Cut that in half, 62.5. That's your third one. And then cut 62.5 in half and get 31.25, and that's your fourth one. 1, 2, 3, and 4. All right, I'm going to clear that, and we're going to go on down to the next group. Try to finish this with one recording, one last recording. All right, so here we have radioactivity was discovered by Antoine Becquerel, B-E, let me check, I don't want to mess it up, Q-U-E-R-E-L. He had 2 graduate students that were Marie and Pierre, P-I-E-R-R-E, Curie. And the scientists found that the uranium ore left a fog on a photographic plate. So that's what made them start thinking, well, that's interesting. What do you think caused that? And then they began to discover everything about radioactivity. Fission is the splitting of a heavy nucleus. Into lighter, 2 or more lighter. for more lighter nuclei. Plus, you get some neutrons, plus some neutrons. N-E-U-T-R-O-N-S. And those look like what? 0, 1, N. Okay? So that is fission. Fusion is the bringing together. To fuse something means to join it together. Bringing together of two lighter nuclei to make one heavier. Plus some energy. That's another product, some energy. Okay. So I'm going to get rid of that now. I'm going to scoot on down a little more. Let's see, where's my mouse? Oops, sorry. Get out of there. Oops. Alright, so, yeah, I'm still recording. Kind of scared me there. Alright, I'm going to come on down. Carbon dating. And the way that I'm going to define carbon dating is that it is the determination of the age of an organic object. The determination of the age of an organic object by comparing the relative proportions of carbon isotopes C12 and C14 in the object. Oops. All right. Clean that up. Okay, U-238. So I'm going to say I'm going to put a 238 there because that's the mass number. That's what that tells me. I look up uranium on the periodic table. It's number 92. It's going to emit an alpha particle. An alpha particle is a helium nucleus. So then I have something left. So that 238 minus 4 gives me 234. And then 92 minus 2 gives me 90. I look up 90 on the periodic table. And I know that element 90 is thorium, TH. So that's what it looks like, and it's completely balanced. You make sure that the numbers on the top right side match the numbers on the top left side, or add up to that. The numbers on the bottom right must add up to match the number on the bottom left. Sodium 22, so that number comes from right there. And if you look on the periodic table, sodium is 11. I'm going to emit a beta particle, and a beta particle is a, let me think about this, -1 for the charge and 0 for the mass. And so I know that this needs to be a 12 here, and this needs to be a 22 there. And if I did that correctly, okay, everybody all right with that? That's my beta particle. Let me make sure that I didn't make a mistake, because, you know, sometimes I do that pretty well. 0, yep, we're good to go. All right, beryllium 13. Beryllium 13 is Be. It has a 13 at the top. And if you go to the periodic table and look at beryllium, it is number 4 on the periodic table. And it's going to release a particle and decays into beryllium 12. So I have Be 12, and it stays beryllium, so that has to stay 4. And that means this has to be a 0, and this has to be a 1. And the only thing that that works for, if I did it correctly, is a neutron. All right, so I'm going to scoot on down. Complete the following nuclear reactions. 212 minus 4 is 208. 84 minus 2 is 82, so I go to the periodic table and I look up number 82, and if I look up number 82, it should be lead. Okay, then I look at this one, 142, 142, so I need a 0 there. 61, and I need a, I would say a negative 1 there, wouldn't you? To give me 60, and that happens to be an electron. S means solid. So whatever's going on with the reaction, I've combined something that is solid. If there's a S there, L is liquid. So that element or compound must have been in the liquid state, and I do know how to spell. G is gas, so that element or compound must have been in a gaseous state. AQ is aqueous, AQUEOUS, and that simply means dissolved in water. So whenever we make compounds or solutions, I should say, for you to use in lab, they're aqueous solutions because I dissolve everything in water. All right, so let's move on. Well, we're almost at the end. Okay. What is a precipitate and how does it form? I said that a precipitate was an insoluble solid. That forms and separates from a solution. So it typically falls to the bottom of the test tube. And what happens is the cation and the anion are attracted to each other. The cation, which is a positive ion, and the anion, and that's not spelled right there, that should be an A. The cation and the anion are attracted and form a new compound. Okay, the last two should be very, very simple for you. Reactants are written on the left-hand side of a chemical reaction equation. Products are written on the right-hand side. All right, please study. This should be an easy test if you will take the time to study. Thanks.